Good evening all. In this session we are going to see the Boolean expression simplification process. Simplification process is done using three things, that is Boolean laws, K-map and tabular method. In this session we will see only Boolean laws and K-map technique, how to solve them. Now Boolean laws means we already seen some of the Boolean laws, that is absorption property, associative property, commutative property, complement property, De Morgan's law, distributive law in the previous things. Using those expressions we are going to solve those particulars using those expressions. Now see here, and we'll see with one example. I simplify the Boolean expression a dot of a plus b. That is, if I want to simplify this particular thing, I will multiply a with the particular thing. So a dot a is always a. That is a plus a dot b. And when I am using absorption law, a dot a plus of a plus a dot b gives me a value. So this is what the law is used to simplify an expression. Now, when I am taking second example, and if you observe clearly, uh, the given expression ABC, that is plus a bar BC plus a b bar C plus a b C bar. Now when first two terms are observed, I can take BC common. So I'm taking BC, a plus of a bar, remaining terms. So a plus a bar is always 1, you know. Next, when I can take C common from these two particular terms. So I'm taking C common, B plus a bar B, a b bar plus a b c bar. Now this particular expression gives me b plus a b bar can be written as b plus a using a law. Now the same thing, I'm multiplying c inside. From next to two terms I am taking a common. Now if I'm taking a common, c plus b c bar. So this can be written as a into c plus b, that is cb plus ac ab is the finally simplified expression. So this is how you use laws in simplifying your expression. Let's get on to the K-map technique, where you can utilize in representing the K-map for various things. Now K-map is something which is used to represent represent the minterms on it, or max terms on it. Minterms are, that is product of sums, that is represented using ones. Sum of products is represented using zeros on it. You will be having two variable K-map, three variable K-map, four variable K-map and five variable. Two variable K-map means if I am having Z and Y as two variables, so y can take either 0 value or 1 value, z can take either 0 or 1 value. So this particular box is going to represent 0 0 0 1 1 0 and 1 1. So minterm will be m0, m1, m2, m3. So this is how the representation for two variable K map. Coming to three variable K map, for three variable K map I am considering three variables to be x, yz. So x can take either 0 value or 1 value, yz can take either values 0 0 0 1 1 0 1 1. If you observe clearly, it is not 0 0 0 1 1 0 1 1, it is 1 1 here. Why? Because the representation that we are doing on K map is gray code representation. So the value will be m0, m1, m3, m2, m4, m5, m7, m6. So this is what the representation goes for three variable K map. Now coming to four variable representation, the four variable representation is like this: AB on one side, CD on the other side. So AB can take 0 0 0 1 1 1 1 0 or 0 0 0 1 1 1 1 0. So the box value will be 0 0 0 0. That is 0 value, 1 value, 2 value, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, 10. This is 11, 12, 13, 14 and 15. So this is what the representation goes with the four variable K map. Now coming to five variable K map, in five variable K map I am going to have two K maps with one first K map value a stands for 0, second K map value a stands with 1. So the representation is of same way. If you observe the minterms here, the minterms are like this: m0 to m15 are on first K map, m16 to m31 are on second K map. Now what, like using these boxes, how we are going to solve? Let's get on to the grouping of cells. Now how the grouping can be done? The grouping can be done like this. The grouping should be of 2 ones, 4 ones, 8 ones, 16 ones together. Means I can group, these are the few of the examples. Now if you can see, I cannot group 1 and 0. I can group only 1 ones. I cannot group diagonally. I can group only horizontally or vertically. Now this grouping is done. Now I cannot group this L-shaped thing. I can group these four ones. So these are some of the grouping of cells. By grouping only I can reduce the number of uh, variables. Now if I am able to group eight once I am grouping together. So if that is 2 power 4, sorry, 2 power 3 means I am able to decrease 3 variables in my expression. If I am grouping 4 cells together, that's 2 power 2, that is means I can remove 2 variables from the expression. If I am able to group 2 cells, that is 2 power 1 means I am able to remove 1 variable from my expression. If I am able to group 16 ones together, so I am able to remove 4 variables from my expression. So this is what you need to understand, how we are going to remove the variables from the given expression. Now one more thing that you need to observe, that is the topmost the topmost column is always adjacent to bottommost column, bottommost row. The leftmost column is adjacent to rightmost column, means all these four corners are also adjacent to each other. That is what you need to understand. You need, if you see an exam, so that you will get more clarity about this thing. We'll start with an example so that you will understand with an example clearly. Let us go with three variable, then with four variable. Now for example, he has given an example, f of abc as three variable input variables which are having min terms. Summation means min terms, pi means max terms. So summation is min terms 1 3 6 7. So min terms are represented with ones on k map. Now I have taken three variables, a on one side, bc on the other side. A can either hold 0 value or 1 value, b can take either 0 0 0 1 1 1 1 0. So these are the things which are I can represent on K map. Now 1 3 6 7. So 1 I have marked, 3 I have marked, 6 I have marked, 7 I have marked with the ones. Now grouping should be done. So I am taking these two ones, I am taking these two ones. I have possibility of taking these two ones also, but if I am taking these two ones, I am left out with these single ones which cannot be grouped with other groups. What happens if I am taking this one also, I should group these two ones, I should have grouping these two ones also, which is giving me more number of groups. My target should be always I should group the ones with the maximum number of cells which is having less number of groups, means I should have more grouping cells with a less number of groups. Now when I grouped like this particular thing, these two ones, uh, these two ones is giving me, we'll mark it again, these two ones. On the left hand side the value of a is 0, that is a bar. If I top observe, it is 0 1 and 1 1, means this value is b bar c, this is bc. Here b bar is changing from b bar to b, but c is remaining constant, so I'm taking a constant value ac. So this particular group, the left hand side value is a, on the top it is bc and bc bar. So b is constant thing, so my final value expression contains ac, a bar c plus ab as my final expression. Let's see with four variable came up so that you will understand, will get more clarity about this thing. For example, if I am having this particular expression, f is, he has given f of p q r s, means he has given, is telling that it is a four variable k map you need to use to solve this particular min terms. Now if you observe 0 2 5 7 10 13 15, I have mapped everything on my k map. Now I told you all four corners are one group, so I am grouping all four corners as one group, and remaining I'm grouping it to 4 1. Now when I taken this particular thing, left side 0 1 1 0 means first initial bits are changing, next bits are not changing, constant. So q is constant, I'm writing q. On the top 0 1 and 1 1 means s is constant, so I'm writing s here. All four corners, if I'm taking all four corners, 1 0 and 0 0, so 0 is constant, that is q bar. On the top side 0 0 and 1 0 means s bar is constant, so my final expression is qs plus q bar s bar is my final expression. Now if we observe the same thing, if you see here, pi of 0367, pi means product of sums, means I need to represent these values with zeros, so I am representing these values with zeros here. Same thing, grouping will be the same thing here. Next, there will be a don't care condition which will be given along with our terms. Now yes, this is one example. With this example I can explain you more clearly. For example, this is the given expression. Now this is my given 1 5 6 12 13 14. Let's decrease my pen size. Next, 4 is the don't care condition. So don't care should be represented always as x on K map. X means either it can take 0 value or 1 value. So that's the reason I'm representing a cross mark on my K map. So 4 values means 0 1 double 0. This box value is 0 1 double 0. So I'm marking with x, remaining all min terms with 1 1. So I'm grouping. I can group y as it can take 0 or 1 value. So if I'm considering it to be 1, so this will be one group, this will be the other 4 group, and this will be a 2. So using this particular thing, I can get my minimized expression. Now if you see, this 4 ones is giving me b c bar, this 4 ones is giving me b d bar, this particular 2 ones is giving me a bar c bar and d as my minimized expression. Along with if min terms are not given, if product terms are given, if you see the product of 6 7 8 9, remaining are don't care. D is the symbol which is used for don't care conditions. Now the same thing I have mapped here, all don't cares with x and product terms with zeros. So here I am making 16 combinations, so I have grouped it here 4 combinations. So that 16 combination along with 4 combination is giving me a bar of b bar plus c bar. This is a bar condition 4 ones. 16 combination, 4 combination is giving me b bar plus c bar. So this is how you represent K maps with the don't care conditions, and there are some of the significance of don't care conditions here, and this is what you need to follow in solving the Boolean expressions. With this we'll wind up our class here. Thank you everyone.